Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given a sorted array and we have to remove all the duplicates element from this array. To understand this problem, let's see few examples. So here we have an array, and in this array you can see that there are numbers 10, 10, 10, 20, 20 and 40, 40, 40. As you can see here, there are multiple copies of 10 present in this array, and similarly multiple copies of 20 and multiple copies of 40. Here, removing duplicates doesn't mean that you have to remove all the duplicate elements and create new array and then copy all the distinct element to the new array. What you can do here, you can just bring all the distinct element to the beginning and then simply return count of distinct element. That's it. This is what you have to do in this problem. So for input like this, as we can see that 10, 20, 40 are distinct element. So we bring all the distinct element to the beginning and we keep all other spots intact. It means we do not care about all these remaining elements. We just care about these three elements that are distinct. So that is why the output of this input is 3. Let's move on to next example. And here you can see we have 3 elements and all are same. It means we have one distinct element and 2 elements are copies of that element. So in this case, we just bring the distinct element to the beginning and return the count of distinct element. That's it. So I hope now you have a clear understanding of this problem. So let's pause the video and think about the solution to solve this problem. Let's talk about the idea of brute force approach. So here we are given an array and there are 7 elements in this array. But one more thing we are given, that these elements are sorted in ascending order. And this is really an important point. Why? Because if the numbers are arranged in ascending order, then it is really easy to keep track of previous element. It means if we are at this index, we can easily find that whether the previous element is same or not. The reason is simple, because these arrays are sorted in ascending order. Imagine what would happen if you get jumbled array like this. In this case, you are never going to find that whether previous element is same or not, right? But here, as we have multiple copies of same element, we can easily find out that if the previous element is same or not. So what we do in this idea, we simply create a temporary array of size exactly same as the given array. And then we assume that the first element is always going to be there in our result. Okay? Because even if the array is given as 1, 1, 1, 1, 1, then obviously 1 is going to be there in our response, because this is the distinct element and we do not care about the remaining copies. So that is why I am including first element in my result. And then we are going to traverse this array from second element. And we are going to compare this element with the previous element. 1 is equal to 1. It means we do not want to include this element because this is not a distinct element. And then we move our pointer to next element. Here we compare if 2 is equal to previous element or not. This time 2 is not equal to previous element. So we include 2 and we increment our result variable by 1. It becomes 2. Now we go to next element. We check if this is same as previous. This is also same as previous. So we simply ignore this. Then we go to next element. Here we compare, is this same as previous? Okay, this is not this same as previous. So we include this element and we simply increment the value of result by 1. It becomes 3. Then we go to next element and do the same process. And then again we go to next element, we do the same process. In the remaining cases, we do not find the unique element. So now we got the distinct element as 1, 2, 3 and the value of result is 1, 2, 3. Now what we have to do, we simply have to copy all the values from temporary array to main array. So after copying all the values from temporary array to our main array, our array would look like this: 1, 2, 3, 2, 3, 3, 3. And the value of result is going to be 3. It means there are 3 distinct elements present in this array. Okay, great. Now what happens if you get array like this: 1, 2, 3, 4, 5, 6. In this array, we do not have any copies. All elements are distinct. So if we follow the same approach, this one, then it's going to work on this array also. And we get our result as 1, 2, 3, 4, 5 and result is equal to 1, 2, 3, 4, 5, 6. Okay, so it's going to work in this type of array also. if we have all the unique elements. Okay, so this is just an idea to solve this problem. Now let's see the implementation of this brute force approach. So here we have a function remove duplicates, and this function is taking array as input. In the first line, we are creating our temporary array of the same size as the given array, and we are storing first element in the first index of the temporary array, and we initialize the count by 1. It means till here we have one element in temporary array, and the count and the value of count is 1. Okay. Now then we are running a loop from first element to less than equal to array.length, and in each iteration we are checking if the element we are traversing is not equal to previous element or not. Now here you can see that count variable is doing two things. The first thing is it is keeping track of all the distinct element, and second, it helping us to find the previous element. So why it is happening? Because if we have two elements in array and the count is 2, you can simply find the index of previous element. How? This is at 0 index and this is at 1 index. So if you subtract 1 from 2, we get 1, and this is the index of the previous element. So this is how it is working. And if we found that both the elements are distinct, then we are simply storing the distinct element on the temporary array and then increment count by 1. Okay, and here count element is again helping us to store new elements. How? If the value of count is 1, it means we have one value at index 0, right? So we can store new element at index 1. Let me show you once again. Let's say this is an array. We have one element at index 0 and value of count is 1. It means we have one element in this array and this element is present at index 0. Now if you want to add new element, then we can simply use this index of C to store new element here, because this is index 1. So we can simply store new element here and increment count by 2. So this is how our count variable is helping us in 3 ways. First, to give the count of distinct element, and second, to know the previous element, and then third, storing the new element. And once we are done with this loop, we are again running a loop from 0 to less than count. So to again copy all the elements from temporary array to the main array. And after this loop, we are simply returning the value of count variable. Okay, so far so clear. So let's quickly try run this code and see how it works. So here we have array with elements 1, 1, 2, 2, 3, 3. Okay. So in the first step, we are initializing new temp array with the same size as the main array, and we are initializing count by 1. In first iteration, the value of I is 1. The element at position 1 is 1. We check if 1 is same as previous element. So we are compared this two term. They are same, so we are not going to do anything. In next iteration, our I becomes 2. The value at index 2 is 2. We compare 2 is not equal to 2 this time. So we enter 2 in temporary array and increment count by 1. So our count becomes 2. In next iteration, our value of I becomes 3. At third index, the element is 2. And 2 is exactly same as the previous element. So we ignore it. In next iteration, the value of I becomes 4. The element present at index 4 is 3. And 3 is not equal to previous element. Both are different, right? 3 is different than 2. So we simply include 3 in temp array and increment count by 3. In next iteration, our I becomes 5. We again get 3 and 3 is same as previous element. So we simply ignore. And in the last step, we are going to copy all the values from temporary array to main array. So this is how it works, and we get our output as 3 because there are 3 distinct elements present in this array, 1, 2 and 3. Else all other elements are copies of these distinct elements. Okay, so far so clear. Talking about the time complexity of this problem, our first loop is running n times, right? Even in case you get array like this 1, 2, 3, 4, 5, it's going to run 5 times. And the second loop also going to run n times in worst case. If you get array like this, you are going to run both the loops n times. So in worst case, the overall time complexity comes out to be big of n. Now, what about space complexity? Here we are using one extra temporary array. So that is why the space complexity comes out to be theta of n. And here n is equal to number of elements present in the array. So far so clear. But can we do it better? What if we do not use extra space? Can we solve this problem without using any extra space? Can we solve it in theta 1 space? Now observe this problem and think about the solution to solve this problem in theta 1 space complexity. Now let's talk about the idea for efficient approach. So we have an array like this. In this array we have elements 1, 1, 2, 2, 3, 3, and these are all the indexes of these elements. And we are given that these elements are arranged in sorted order. It means increasing order. So this is a really important point. As I said before also, using this fact we can easily track if the previous element is same or not. If we would have got jumbled array like this, then it becomes very difficult for us to find if previous element is same or not. Right? Here elements are arranged in increasing order and there are copies of element. So the copy of these distinct elements also appears after the distinct element. Right? So in this case, can we use just one pointer to keep track of all the distinct elements and previous index of the element? Let's see how we do it. So initially, we are assuming that the first element is always going to be distinct. So we are initialize our count variable to 1. Okay. Now then we start traversing from the second element, and the value of second element and the element present at index 2 or second element is going to be 1. And we check simply that if the 1 is same as previous element or not. And how we get previous element? We simply do 1 minus 1, means count minus 1. So here count is helping us in two ways. First, it is keeping track of all the distinct elements and it is helping us to find the previous element, because c minus 1 is going to give previous index. So we check if 1 is equal to previous element or not. In this case 1 is equal, so we simply ignore it. And then we simply go to next index. Next index is second index. At second index we get 2. We check if 2 is same or not. Now this time 2 is different, so we simply increment the count by 1, so the it value becomes 2. And after increment count by 1, we are simply going to include that new element in the same array. Means this time we are not using any extra array. We are storing that element in the same array. Okay. So after storing 2 at position 1, our array looks like this: 1, 2, 2, 2, 3, 3. And the element present at index 3 is 2. So this time 2 is same as previous. So we have to follow this process for all the indexes. And at the last we get our output as 1, 2, 3, 2, 3, 3. You can see that we bring all the distinct element at the beginning, and the count of distinct element comes out to be 3. It means there are 3 distinct elements in this array. So this is the idea of efficient approach, that we just have to use the one pointer. We do not have to use 2 loops or any extra space to solve this problem. We can just use one pointer to solve this problem by simply keeping track of the previous element. Now let's see the implementation of this efficient approach. Here we have removed all the unnecessary code. So here in this code I have removed all the unnecessary code, and this time we are not using any extra array to keep track of previous element. Okay. So in the beginning we are initializing count by 1. It means we are assuming that the first element is always going to be the distinct element. And then we are running loop from 1 till array.length. And inside of this loop we are checking if array of I is not equal to array of count minus 1. This is the same way this is the same code we have used in the previous approach. Okay. And if it is not same, then simply storing, and if the element is not same, then we are simply storing this new element in the same array itself at the position of count, and then we are incrementing count by 1. And after for loop we are simply returning the value of count. So let's quickly try run this code and see how it works. So this is our array where 1, 1, 2, 2, 3, 3 are elements. We are first initializing the count variable by 1. In first iteration the value of I is 1. The element present at index 1 is 1. We compare if 1 is same as previous element. This time it is same, so we simply ignore this case. In second iteration our I becomes 2. The value present at index 2 is 2. We check if 2 is same as previous element. This time it is different, so we increment the count by 2. So before we increment this count, we are going to store this new element at the position 1. Means now our 2 comes here. And then we move to next iteration. In next iteration our I becomes 3. Element present at index 3 is 2. And 2 is same as previous element, so we simply ignore it. We move to next iteration. In next iteration I becomes 4. Element present at index 4 is 3. 3 is also different than previous element, then we simply store 3 at index 2 and increment count by 1, so our count becomes 3. And in next iteration our I becomes 5 and the number present at index 5 is 3. We check if 3 is same as previous element, it is same, so we simply ignore this case. And this is how our loop gets completed and we get our output as 3. It means there are 3 distinct elements present in this array. Now here you can see that how we bring all the distinct elements to the beginning and all the remaining elements remains unchanged. Okay, so far so clear. Now talking about the time complexity, here we are running loop from 1 to array.length. Means we are running loop in times. So the time complexity in worst case comes out to be big of n. Why we are giving upper bound? Because if we get array like this 1, 2, 3, 4, 5, here you do not find any duplicate elements, then your loop is going to run 5 times. That's why the time complexity is going to be big of n. And if I talk about space complexity, here we are not using any temporary array. We are simply using one counter variable and the array given as an input. So that as we are not using any auxiliary space other than these 2 variables, that is why the space complexity comes out to be theta of 1. So it means to solve this problem, we are using theta 1 space and big of n time. So we have successfully solved this problem in theta 1 space. So before we end this video, let's have a quick recap of what we have done so far. So we are given an array and this array contains distinct elements along with the duplicates elements along with the copies of that distinct elements, and this array is sorted in ascending order. We saw the brute force approach to solve this problem. In that approach, we are using one temporary array to track the distinct element, and then we simply copied all the distinct element to the main array. To solve this problem, the time complexity came out to be big of n and space complexity came out to be big of n, as we are using extra space here to solve this problem. Then we saw the efficient approach to solve this problem. In this approach, we are simply using one pointer to keep track of previous element. And to solve this problem, the time complexity came out to be big of n and the space complexity came out to be theta of 1. It means we have solved this problem in constant space and big of n time. So this is it for this video. Thanks for watching. See you in the next video.